Mostly excitement, not.
Yeah, I know.
I mean,
Don't ask difficult questions. The difficult questions will come from the audience. The difficult questions.
Actually, what happens? Any change is there is always opposition. Always
It's natural. It's a human tendency.
people don't want to change. And they don't want to learn.
So, see, there is a chain related learning, right? And only when you start enjoying that beyond the point, then it's okay. No pain, no gain. Very good.
We used to come to Goa to teach. Yeah, and visiting practically. Then we had a lot of interaction in Kia actually visit, but the thing is, I stay here to block all the people. So, block the
हाँ हेलो काय करता Yeah, we can start actually.
Check the file.
Joel, take photos and videos. Okay. Fine.
my father's friend, my father medical travel.
हाँ वहाँ से रहो
Okay, so after the presentation, we discuss this.
Yeah, that is better. टेबल काढून बाहेर करूया
फाटल्यान भरया पण टेबल काढल्यार एकले व्हिडिओ
बुक पण देतो
आय डोंट सी तुमका एकदा तुम्ही शिकायला म्हाका
किती
आर्यन
अरे नाही
एक कोणता तरी टॉपिक शिकोवपाक येता तुम्ही
तुम्ही पण स्टुडंट नाही
आम्हाला काल मेळपा आशिल्लो याद जायना खंयचो मी आयिल्ले ते याद आसा तेन्ना 11
किती बरं तुम्ही
This is my classes are
काय तुझे क्लासेस घेते
ऑनलाईन आसा आणि पणजे आणि मडगाव आसा अच्छा एकटाच घेता
क्वालिटी होता चढ माणसं घेतले की क्वालिटी
एकट्यानूय घेऊन
ते सांगत पण व्हेरी डिफिकल्ट टू गेट गुड बरं आता असं बरं जो गुड असलो नाही येईल पुढे टेक ठीक आहे बरं असं म्हणून घेतलं नाही
So I do very different things with the kids. I don't do like regular kanna. Probe karta at a young age, 6 standard, 7 standard. I like teaching that age.
प्लेजर
That is all what I sustain me. Nothing else.
Huh? No, I'm here. I'm in the hot seat.
भाई बताओ तू दोन चेर अशी दोर ते मागीर सकयल्ले लिपतले
ते बसले आणि त्याच्या तोंडार पडतले
आता न्ही रे प्रेझेंटेशन जातलें
You don't need the chair.
पयलीं प्रेझेंटेशन आसा मागीर ते आसा ती येवचे ना स्टेजीर आतां ती सायडीक दवर सद्या सायडीक दवर एंडाक हें अशें एक सकयल देव
Okay, we'll get started.
Good afternoon, everyone. We will now start with the panel discussion. As a moderator for the discussion, we have with us today Professor Venkatesh Kamath. Good afternoon, everyone. We will now start with the panel discussion on NEP and mathematics curriculum. As a moderator for this discussion today, we have with us Professor Venkatesh Kamath, retired professor of computer science at Goa University and currently a visiting professor at IIT Goa. I request Professor Kamath to introduce our panelists for today and get started. Thank you.
Good afternoon to all of you. Can you hear me at the back? So, I have a panel which consists of 2 senior professors, and then we have invited 3 Goa-based mathematics teachers from 3 different generations, as I was mentioning to you yesterday, right? And what we will do is we will request the youngest member of this panel first to make a presentation giving little perspective about NEP 2020 recommendations and what its implications are. And then I will invite all panel members to give their initial remarks. And certainly we will be open to the questions from the audience, right? So we may have some few curated questions and then maybe a question from the audience, okay? So let me introduce you to the panel. We have Professor R. Ramanujan, former professor from the Institute of Mathematical Sciences, Chennai, and currently a visiting faculty at Azim Premji Institute, Bangalore, Azim Premji University. Okay. Then we have Professor Madhavan, whom we just heard, Director, Chennai Mathematical Institute, and currently he was also past president of ACM India. I mean, that's another thing that we know about Madhavan. And currently NCRT chair of school mathematics curriculum from classes 6 to 12. We have Professor S.U. Kamal, a retired college professor, and many of you, I'm sure, you will know Professor S.U. Kamal. He has been our teacher for last 5 decades. He has been teaching mathematics at various colleges and institutes in Goa. Then we have Ulpa Vaingankar. Currently, she is assistant professor at Padre Kosasam College of Engineering. I mean, she has around 15 years of teaching mathematics at various colleges, different programs under Goa University. And then we have young Siddharaj Mokkar, NIT Calicut Engineering graduate and a Teach India fellow, and who has been teaching mathematics foundation classes to young students just out of passion for teaching, right? So we have Siddharaj with us. And to begin the session, what I would do is I would request Siddharaj to give a little brief about the NET. So then this is the idea, just that we are all on the same page. And many of us, frankly speaking, me, have not really studied the details about the NCF 2023 mathematics curriculum, that has been recently released, right? So let's hear Siddharaj first. He will make a formal presentation and then we will invite the panel to resolve here.
So, thank you, sir. I'm here to set context for the panel discussion that is going to happen right after the presentation. My comments on the NET and whatever NCF holds for us in the near future comes from my experience of teaching young kids from the age group of 10 to 16. So largely what I have put on here is my own understanding of NET. So I was teaching all these kids outside school system. I had an after school program running. But what happened in the last year was some of the parents approached me. These parents were in the government, and they said, the Goa result for maths looks like this. We have underperformed at every level in mathematics. So what can we do about it? Can you just go through it, read? So that's how I got exposed to what this is, right? So if you see across grades, grade 3, 5, 8 and 10, Goa is underperformed compared to the national average. Not that the national average is great, but we have underperformed, right? Yeah. So this is just for all of you to see the questions. I'll just read out 1 or 2 questions. These are sample papers of NAS. The original papers are not really available to the public. So it says 9099 divided by 3, what is the answer? So they're pretty straightforward questions for class 5th, and that is the result is we have just scored 30 to 40%, right? So clearly there is something going wrong in our system. There is the children are not really learning well. And if you look at that, why is that happening? Why is it that the children are not learning? And yesterday when Dr. Montero was speaking here, Dr. Vivek Montero, and he mentioned that, right? So we have really made math a procedure. We don't really regard our kids as humans capable of thinking on their own. What we have done is we have taken this one thing that is there in the textbook and we have tried to drill it into the student and asking him or her to do the same thing that is being shown in the textbook or what the teacher knows, right? So I have had students come to me and say, I did it this way and the teacher said it's wrong. So this happened in Goa. For example, a child studying in 3rd standard was asked to represent 2 multiplied by 3. So he wrote 2 times 3. So he wrote 2 plus 2 plus 2. Whereas the other child wrote 3 plus 3. So the 3 plus 3 was given marks because 2 times 3 is 3 plus 3. But 2 times 3s 2 plus 2 plus 2 was told that this is wrong. And when he went back, I realized that it's clearly a language issue, because when we learn it in Marathi, for example, we say Bekrik Saha. We don't say. These sort of issues are existing at the school level, where we are just trying to not give importance to language. We have made numbers as things which are just. So numbers become things. Numbers are not things. Numbers are representations for things. So I will come to that later and set the context for that as well. So another thing I wanted to put forward to you is, just imagine the best student in your class, best student who tops mathematics, right? And what you will find is that student is largely great at remembering steps to get to the final answer. So what drives our mathematics education is the assessment, and our assessments are largely going towards the final answer, and that is what drives our learning. So even the best student in our class, in my opinion, is not really learning mathematics per se. He is learning how to follow orders without thinking about it for himself. Yeah. So what does NET say? So NET says that you need to engage in problem solving, connect theory to the real world, right? How much of this is really happening in our classrooms, right? And it says you need to communicate mathematical ideas. I want to put this question to all of you, like, how many of us talk about mathematics at times other than the math classroom time, right? Do we talk to them about mathematics outside their classrooms? Do we encourage discussions between kids outside the classroom, right? And another thing that it also says is you need to engage them in open-ended discussions. I would not say solutions, discussions around mathematical ideas, which is what Mr. Madhavan also said in his previous talk, right? So there are challenges to the potential changes that could happen, and largely, when we ask teachers, the one thing that comes about very loudly is that we need to complete the syllabus, and in this urge to complete the syllabus, we have forgotten the learning bit of it. Yeah. I'll go to this later. So what I want you to think about is that as teachers, we actually have a power. We have the power to change each student one at a time, right? And then each classroom that we teach one at a time. And yesterday, while we were sitting in the math lab activities, while Aloka and I don't know the other instructor's name, while they were doing the activities here, I was sitting with our Ramanujan sir, and we were doing those what is called Power of Hanoi thing, and while Aloka came up with that explanation, that she said, that there is that one student of mine who came up with this explanation where the largest one just does transfers it once, or then 2 and 3 and 4 and so on and so forth. Ramanujan sir said, this was something I did when this was my first proof, he said. And I was like, okay, this was his first proof and he remembers it. So what I think is we just require, our kids require just that one moment to say that, I can do it. That yes, I have done it, for some people who are struggling. For some people, it's just, I can do math, right? And once that happens, I have seen some examples where students have gone on to learn much more than what I even expected of them during that time, just because they fell in love with mathematics. So this is just a rough framework around the same. We've read these words in the NEP and everywhere else. We talk about conceptual clarity, but we don't really know what conceptual clarity can mean, and it often takes effort on the parts of teachers and on the part of your student group to engage in these discussions, to be able to understand what concept is. So I'll just give you one example. So 2 years back, during the pandemic, I asked my students about, we were doing place values, right? And so I was like, how would the prehistoric man have counted things, right? So then they went about 1, 2, 3, 4. Oh, I don't have any more fingers left. So, oh, he put a pebble inside his pocket. Now that's where the whole things about the place value system starts. But then we explored, why do you add the way you add? Why do you subtract the way you subtract? Why do you multiply the way you multiply? And for the first time in my 25 years of learning mathematics and having gone to undergraduate course and learning mathematics, I realized why the division algorithm works. As a kid or as an adult, I have never asked this question, but when I opened it up for the students, they asked it and they themselves answered it. Right? So there is that possibility of learning if you give math time, if you let the child think for themselves. So largely, we need to move away from just the final answer kind of, closed answer type questions to, maybe allowing the kids to talk about mathematics, to simply ask, okay, if you see a percentage, what does this mean? What is this? What does that symbol mean? Because largely mathematics is representation of some other idea. What has happened is for us, math has become numbers. Largely, those numbers are just the symbols, right? So, do we talk about representation in our classroom? Do we talk about the fact that numbers are not really numbers are just constructs that you use to represent something, right? And then again, like while doing fractions, do we ask them how to add fractions geometrically, not just through the rote memorization of making the denominator common? Or why do we make the denominator common in the first place? What does the denominator decide? What is the role of the denominator versus numerator? Are they the same? Was this the representation throughout history? So things like that which pique certain students' interest. Yeah, I'll just move ahead because I think if I spend time this will go on. Yeah. So even in algebra later on, like how we can make use of combining algebra and geometry, which only happens in 9th standard for a bit in our curriculum at the moment, where there is coordinate geometry as a chapter, but we don't really have algebra like connecting to geometry until we see calculus in 11th standard or 12th standard, right? So that maybe needs to be done. I'll just go ahead. Another thing is mathematics and other subjects. So you have any mathematical concept is largely a tool for any other subject to to communicate basically. So you're basically communicating ideas about physics through mathematics. So mathematics largely becomes a tool, or language rather, and that is where I brought in things like expressions could be like phrases and sentences and so on and so forth. Yeah, so I'll just not take much time and I'll just quickly conclude. So the largest thing, the most important thing, whether the curriculum comes or not, is that what happens in the classroom is the implementation bit, right? Whether the curriculum says it or not, if it is not happening in the classroom, it will not happen. So the changes will not be seen. So the first thing is, first and foremost, there should be a pedagogical shift, and whenever there is a change in methods, there is always resistance. There is always resistance from self. There is resistance from parents. There will be resistance from students as well. But I think it's a long-term exercise where we have to engage engage for a long time in this whole exercise of making parents aware, making students aware, and making ourselves aware in the first place that we will change this, right? And then also we have to talk about inclusivity in learning. I understand that sometimes it's not possible to take everything for every child, right? Usually the teacher decides what's the median for most kids, what can be taught in that child. So those are challenges that we still have, and the most, what do you call it, the least of the challenges that we have are infrastructure and resource availabilities, because things like CS Pathshala, and if you see their curriculum, it is, you don't really require tech to learn about tech, right? So that's not a big constraint, but the others are. The first one is, it's a very important one. So yeah, what can we do from math curriculum? First thing is, our syllabus is right now in silos. So if you ask a child from 6th standard, he would say, fractions and decimals are two different chapters. I don't understand how to connect the two. Right? They would say, if you give them something in decimals, they would say that chapter is not there for us. That's how it starts, right? So students have formed these schemas around these chapters, and they have placed everything in different boxes, which needs to be broken, and maybe the chapters need to be connected, interconnected, because there is a flow of things. There is a connection between every mathematics chapter with the other mathematics chapters, and also using other methods, like for example, fractions might be taught as arithmetic but can be represented geometrically, things like that. Also simplifying mathematics vocabulary. So for example, I would have these kids come up to me and ask me things like, what is that adjacent angle, what does adjacent mean? If you look at the Tamil Nadu textbooks or the Kerala textbooks, they have simplified the language for us. You have to see these books, SCRT Kerala textbooks. They have simplified this language. They've called it just adding angles, because if they are placed next to each other, you would add them, right? So there are no jargon like adjacent angles, or you need not remember what is corresponding angles. If you draw two parallel lines with a transversal, all that is formed is two obtuse angles, like two kinds of angles, obtuse and acute. All obtuse angles are equal, or acute angles are equal. If you add them up, they are 180. Why do we need the kids to learn about what is alternate interior angle? I don't know. That's just a proposition that I'm placing, right? So maybe the vocabulary needs to be simplified. And lastly, Kerala textbooks have done that. So there is a QR code along with the textbook where you can scan that QR code. It takes you to GeoGebra, or I think largely GeoGebra. It takes you to, and you have other apps that you can connect with our textbooks. So yeah, that's about it, and let's start. I'm very sorry for taking so much time. Yeah.
Thanks for the feedback.
Okay, thank you, Siddharaj. Now I will invite the panel onto the stage, because people can see their faces also while they are answering the questions and giving their remarks. Yeah, come please. Where is this Ulka Please get me. Shift one side here. I think that's Siddharaj is there, right? No, so that's what I'm saying. So shift one line. No. Shift operation one. Only one, please.
No, I think he can just come there. So I think they have managed to squeeze it.
We realized this a little late, that their faces would not be visible. They say down. Okay. Yeah, hello. Can you hear me? Yeah.
Hello. Hello. Hello.
Hello. You can hear me at the back? Okay.
At a distance, of course, by plane.
So to set the ball rolling, let me make one provocative statement so that that will make you think. So what I want to say is the interaction in the math class is very limited. By and large, the maths teachers prefer to do chalk and talk, which leaves very little time for them to interact. And current generation of students are very visually oriented. They have a very short attention span, and they find the stereotype teacher and a stereotype teaching boring. Okay? And just blaming the students, saying that they are lazy, they are not disciplined, they are not serious about learning. I think these are the challenges that we have to face, and there is no other alternative, right? I mean, these are the conditions under which we need to perform. So the challenge to the teacher today is, how do you get them engaged in the class in spite of all these distractions that they have? This is not the generation like ours. We didn't have these many choices and these many distractions as compared to the current generation. So these are the challenges. So the question is the current curriculum, the current recommendations of NEP in terms of so-called changing the pedagogy, bringing the interactivity in the classroom, how are we going to do that in the current context in the mathematics teaching, right? Maybe the other subjects, maybe they have an equal set of challenges, but since we are discussing all this in the context of mathematics, I would like to hear from the panelists as to what is that they think that can be done. There are challenges. So if anybody wants to have some initial remarks before we get started, I would request the teachers to say so. I mean, you have any initial remarks about NEP and something that the context in which I'm talking about? Yeah, you have a mic. Okay. So we'll first give a voice to the Goan teachers before we hear from the senior. They have much more experience on a wider at the national level. Yeah.
To begin with, I have to make a very strong comment. The most of the textbooks that are available, they are not at all attractive. Horrible. When the printing technology has increased and such a fantastic thing is available, you can have a colorful textbook. There are some publishers who are coming out, not standard textbook, but their books are being used by students and not recommended textbook. And in this context, I would like to I happened to accidentally come across one book. It was in my college library, never used by anybody. It was published in somewhere 1969. This person, his name is George Papy, P-A-P-Y. He's from, I think Belgium. And he was working in a university and all. He and his wife is also mathematician. Her name is Frederick Papy. They have written done the experiments on all how to teach in the schools and all. And he has come out with a book in 1969. I will give all the Modern Mathematics, Volume 1, Volume 2. If you open the book, you feel like seeing it again and again. The way it is written, the way it is printed, the way the questions are asked, the way the subject is introduced, the way the applications are given. And whether it is a function, set theory, logic, you just name it, he has handled it. Modern Mathematics, Volume 1, Volume 2, George Papy. ISBN number also I am giving because that is important. 978.
No, that's, you can give it to them.
Okay. Publishers are Collier Macmillan. Now this Belgian book is translated in English. English people are extremely arrogant. to say the least. They will not recognize any other country. But this book, being printed in England, shows the quality of the book. And it can be read by some 9th, 8th, 9th standard student onwards. Varieties of things have been put there in 2 volumes and all, and many other books he has come out with. So the book should be, first of all, attractive. You must feel like reading. It should not be like a law book. Then the questions. The questionnaires that are given, the same routine things, thousand problems. There should be some innovation that is missing. So first part is book. Second word, we need to understand how mathematics is to be read and to be written. Yesterday I was discussing, and I was just discussing one small problem. I said that our voltage that is in a country is 230 volts. It's an alternating current. So what is written there is the average voltage. It is called RMS voltage. Now what is RMS? So people will say root mean square voltage. But now the question comes, which operation to be carried first? Whether root or square or mean. So root means square. So the convention that is followed very strictly is from right to the left, RMS. So first square, then mean, then root. For example, we say greatest common divisor. So find divisor, among divisor find the common divisor, and among common divisor find the greatest. This is how it should be followed. This is to be understood by the first teachers. If the teachers do not know this, the student will not know. So these are the 2 things that is to be remembered very well. Third one, and my experience of, unfortunately or fortunately, I have practically taught most of the courses up to postgraduate level or even postdoctoral level. I find logarithms not been properly understood by the students because teachers do not know. There are 6 laws, and I will of course give a small handout to Dr. Kamath, and he can send an email on all that. But logarithms, which is most commonly used, but people do not know. When I was in a pharmacy college teaching there, one M.Pharm student came running, and she told me, "Sir, this logarithm under my calculator is wrong." For example, log of 3 is 0.4771. Log of 0.3, it will be, we'll say, 1 bar, 0.4771. Now, actually, in calculator, -1 plus 0.4771, it will be negative. So, calculator will show something than what you are used to. So, this is to be understood. And logarithms are used everywhere. Biggest problem in any branch of knowledge where mathematics is used is logarithms. Whether it's integration or differentiation, logarithm create problem. So, take care of this. So I will stop here and I allow my other panelists
hear
to say.
from others also.
Yeah.
So in fact, yesterday when Vivek Montero mentioned about those books, I downloaded some of them from the internet, and really the books are. I mean, it's unfortunate that I'm reading it at the age of 65, something that I should have read much before. I mean, please have a look at the books like calculus, and all these books are written in a language which is very simple to understand, very exciting way of communicating. So I think
Applications.
Professor Kamath, when he's making that comment about the textbook, I think by and large, I think we have seen this problem in many. Maybe printing in color maybe costs more, but there is an issue with the books. Okay. So we will take up the question. Yeah, we will take up the questions. Hello. Okay. Now. You want to say something, Ulpa? I mean, she's from the engineering branch, and engineering has some of its own challenges, particularly when it comes to mathematics teaching and learning.
Yes, as already mentioned, I have taught across branches, not only in engineering, I even taught commerce, science. So basically, one common problem which I came across while delivering lectures in maths or connecting students to maths was they could not relate to what they are studying, where they'll be using. Okay, specifically like when I was teaching statistics for commerce students, like they had the elementary statistics. Why they had that paper? So that when they reach to the third year, they had to do a project was basically collecting the primary data and analyzing it. You put it in the this thing tabular form and representing data in the graph format and interpreting the values. But when we is to teach them in statistics, people barely managed to clear the paper. There was a backlog saying like maths is difficult, statistics is difficult. We just need to clear the paper. The people who really did well were the ones who were answering the CPT exam, the entrance exam for the chartered accountant, or the ones who were doing some extra courses like the secretariat course and so on. So this was a thing like for 2 years I noticed students are barely trying to pass. So what I decided was I'll give them like no preliminary small data assignment of collecting around 100 this thing values, okay, data set of 100, and they can analyze based on what they have learned. Maybe in first year they were learning elementary values like mean, median, mode, how to put it in the tabular form, which is will be the best graph to represent that particular data. Why is it so? That is what was their first time portion. So I told them analyze based on that only. Give me only those analysis. More than enough. Now, if we have a class of 60, 70 projects, are we going to assess? Feasibly not possible, correct? So I divided them into groups. So basically, two ideas or two notions behind this was let them learn a teamwork. And second thing is let them learn to apply what they're doing. Like people knew what they knew how to calculate mean, but when it comes to data set analysis, what mean represent over there, what mode represent over there, how to use it for the further analysis, they didn't know this. And to my surprise, there was a vast difference of how their performance was in their terminal exam, because these were done prior to their terminal exam. People actually understood. So something like this, if we can do even in this thing. Now, this was basically with the commerce college. If I go to the engineering college, over there applications as a maths faculty, I cannot do, correct? Mine is a different domain. So what I did is to create the interest. If before the lecture, I used to show them a video, which I implemented during COVID teaching time. That was the best thing I thought. So show them a video and ask the students which part or which concept you think is applied in this particular application. People came with various answers. Then to their surprise, like, okay, my answer is correct. That motivated them to learn the subject. Second thing, like matrices, we do Laplace transform, Fourier series, Fourier transform. So if I can tell them where this concept will be used later on, like first year, second year, they have maths, third year onwards, they go to their core papers. So if I can tell this concept will be used where in their core papers or to what extent, that helps them to create the interest. And as rightly pointed out, sometimes we should let our kids visualize, because the kids can visualize way beyond our expectation. What we can think as a teacher, they can go beyond that. So sometimes let them visualize. And one thing which I missed out, I think it is missing out in Goa, having such gatherings wherein cross-sectional teachers coming together and interacting. Because as a teacher, which I find difficulty while explaining engineering concept is foundation is weak. As rightly pointed out one of the teachers, derivatives nahi aata humko, integration nahi aata. Why is it so? Now she said it was during COVID times, but I experienced beyond that, like on the regular basis also, people find it difficult. What I feel like most of my kids do only derivatives at the 12th or high secondary level to clear the paper. Integration we left because their basic target was clearing the paper. But if someone have done derivatives, making the child aware of integration to some extent was easy. Imagine a child have not done both the concept. What are you going to do? Are you going to go to the foundation level and do it again? And then when you're going to teach the engineering mathematics? Because you first thing have to identify what are the slow learners and what are the advanced learners. What is the criteria you're using to identify advanced learners and slow learners? And what are the steps taken? Many times I feel as a teacher, we think of slow learners. What are you doing for the advanced learners? In a process, they should not be ignored. I feel we should do something, to foster their this thing visualization, their caliber. thinking about slow learners, they should not be degraded, because most of the time this is what is happening. Imagine a child, a class which is having a 70 student. In that class, there are around 10 or 2 students who are thinking out of the box. Others are falling in the category average or below. So we go by the majority saying like, nee, the class is slow learner. This is a strategy I should adopt. What am I doing for the advanced learners? Because I feel that will be unfair, putting their caliber down. So from my side, what I'll do, I'll tell you, I would definitely love to know what others are doing, because this is a platform where we can exchange ideas. Everyone must be adopting different strategy. Let us exchange, because that will help each other to progress and take the things further. And what I do is I give them extra things like something which will help them to elaborate or understand the concept better. Other, maybe the majority are not able to solve, but he can definitely come up with the answer. There are some kids, they come up out of the box solution. Ma'am, can it be done like this? Ho sakta hai. If it is not, find out. It looks to this thing, first appeal like, nahi, this is possible. Sometimes it is not so. वो method कहीं ना कहीं गलत जाता है. Why is it so? Which law has failed? Why it cannot be done like that? At times in a class, time constraint, we cannot do that. Something is wrong in that, you're not able to figure out. Take it. Tell the child, give me 2 days time, I'll do it. Most of the time, as teachers, we try and solve the difficulties in the class, not required. Even if the child is correct, you make a mistake, it's okay. We are all human beings. Nice. I feel the best part of my side being in a teaching field is I learned a lot from my students. I'm blessed to be around the young crowd, because they help you to progress, they help you to learn, they help you to keep in touch with the technology, to upgrade yourself. That is the best part of being a teacher. In fact, we all should be saying this and feeling this among ourselves, ki yes, being with the young crowd, they help you keep up with the trends. So that's something nice. Make use of it. Learn from your things. I would say I learned most of my apps from my students. Most of it. They helped me during the COVID times to develop that ratio from that equation with your students. That really helps.
Yeah, thank you. Thank
Yes.
you. So, yeah, I think, one thing that I can take from what Ulpa said is, it is better to be frank with the students. If you don't know something, it is better to admit in the class that I don't know now. Okay. Rather than, trying to put that question under the carpet or saying that this is out of syllabus. It doesn't work with this current generation. I mean, they have access to resources just like you, even sometimes better than you. So it is better that, you can admit that I don't know at this point. I was always hesitating to think, see, I can do that to mature students in my class. I mean, maybe I have been teaching at a graduate, postgraduate level. But I'm not sure, have you tried it in your own class? Because you are all human beings, you can make mistakes. How do you handle those things in the class in front of the rest of the, they are seeing that the teacher doesn't know. Right? I mean, it's something that I think you should be humane. I mean, you should have the humility to accept and then, handle the situation rather than, saying, trying to shut that voice, saying that this is something, I don't want you to ask. Right? Okay. The other thing that she mentioned about the videos, I mean, see today, how many of you have seen that 3 brown and 1 blue, right? So those are excellent, 3 brown, 3 blue and 1 brown. Okay, so there are excellent videos explaining something visually. I think this is something that we didn't have at our time. I always was struggling to understand how a function can be represented in a vector space, right? I mean, there was a nice visualization of the whole thing, which made things so simple, right? So I think teachers should be using, particularly at the higher standard, I mean, where you have the resources in the lab, in the classroom or in the laboratory, I think you should provide these resources, not only use it, but also give those links to the students to use it, right? So I have a question to our senior professors who have been teaching at a higher level. Now, coming back to that question that she was saying that, students ask me about the applications, and I'm a maths teacher. I don't know where this application is, right? Now, my question to Professor Madhavan or Professor Ramanujan is, who should be teaching, those courses which have application? For example, a course like linear algebra, should it be taught by the subject teacher or should it be taught by the mathematics teacher? Because I'm sure the approach is going to be different if you're teaching linear algebra to, say, computer science students or linear algebra to electrical engineering students. That approach could be different than if you're teaching it to the mathematics students, right? So I would like to hear from one of you. I mean, I would like you to speak because you have such a wealth of experience. Yeah. Yeah.
Yeah. I mean, I don't know if there is a general answer and a good answer to something like this. That I think this appears everywhere when you teach mathematics. Where is it used? Now, one of the things that we all find, children never buy this logic of you should eat vegetables today because it's good for you for health later, right? So, I mean, there is always this thing of you learn all this today because it will be useful. It will be extremely important for you later. Now, what is that later? How is that going to show up? It's not clear at all. And if somebody who buys it, there is no problem. But for those who don't buy it, right, it is a problem. And why should I do this today? Because someday, somewhere, I must make use of it. Now, this is true whether it's, in the engineering curriculum or, in middle school or secondary school or everywhere, this is a problem. So, in terms of curriculum, one thing that you can think of is that as much as possible, move things to where they are needed, right? I mean, in fact, I think in the NCF 2005, 20 years ago, it was even called principle of curricular postponement, right? If you're only going to do it superficially, just do something a great example is what we do with matrices in class 11 and 12. It's done so incredibly superficially. It's just some way of arranging data in a two-dimensional thing. And then linear transformations, you're talking about all that comes much later. Now, if you're not going to do this in depth where it is needed, better not to do it. Use that space for doing something better. I'm saying that, but it's also very hard to do when, the process of curriculum formation, syllabus formation, textbooks, there is like so many considerations at stake, very hard to do. But the problem is that in general, you learn much better when you see it along with what you are using it for. This is true for most of us. Certain people don't need it. Certain people, and we all see that in mathematics, always they don't care. They just like the thing in itself, and they are able to engage with it as a mathematical construct. For them, there is no problem. But by and large, it is needed. So I have always felt that, for instance, higher secondary or undergraduate calculus would be much better taught by physicists than by mathematicians and math departments. Math departments are usually much better at teaching real analysis and not calculus. Physics people use it enormously and see it in context. And when mathematician V.I. Arnold talking about it, makes a very strong case. And in Russia, mathematics is actually taught through mechanics. Calculus is taught through mechanics. And they find that as the Russians take it as a very serious way of doing learning calculus. So, and it's also true that calculus arose out of mechanics. Newtonian mechanics, as we understand it, is how we look at velocity, acceleration, and that's where d by dx, d squared by dx squared, and all come up. So that's a very good example. Linear algebra is harder because linear algebra goes everywhere, right? But what I would say is that the concept of linear transformation is something that a mathematics classroom has to engage with. Looking at rotations, looking at this and the geometric view of a linear transformation, I think is very important for a mathematics classroom. But then there are a whole lot of computational things that are extremely important, but they are probably much better off in other contexts. Economics, I think provides fantastic examples of, use of linear algebra, where the computational thing matters, the concept matters, all that. Now, we don't have, okay, should this be done by different teachers teaching? Or why can't I walk into Venkatesh's class and teach 2 classes, and why can't we invite a physicist to take 2 classes for us, and economists and co-teach and co-do all these things? We don't have such models, right? So I think it's not simply a matter of curriculum and textbook. Our ways of doing these things, ways of planning pedagogy, doing all that should be a lot more flexible to make room for these things. If mathematics classrooms would start inviting various people to talk of applications and how they actually find very natural applications for certain things, that would be wonderful. In fact, yesterday, Janaki was talking about application to genetics. I have very rarely seen a biologist being invited into a mathematics classroom to actually talk about genetics. It's very likely that a biologist may actually give an air of authenticity to some of the things that we do than what the cooked up stuff that we managed to do, right? But it's actually a good idea to do all these things. So applications, I would say, is probably done best through collaboration, through co-teaching and changing ways of doing this. Books also have to change to make it possible. Today, technology makes it possible for us to navigate material in multiple ways and access material in more ways. We should take that seriously and change the shape of our, content as well in this regard.
Yeah, thank you. That was a good, really in-depth insight. So I heard somebody saying that, the reason why he says move closer to the, where it is going to get used, where they see the application. So, somebody put it very nicely that the students are better motivated to learn a subject when they know that where it's going to be used, right? So rather than just in case learning, he said that it should be just in time, right? Just before you require something, because you're motivated to learn something, it doesn't matter. So I have seen students, particularly when it comes to project, they're excited about the project. In the process, they learn a lot of things. That's why, this project-based learning has its own, advantages in terms of learning. You cannot really set objectives, what you will learn, but I have often seen that when the students collaborate, they learn from each other and they learn much more than what we. So, Professor Madhavan, now it's your turn. Anything that you would like to say about, you have taught computer science, you have taught mathematics, so, and then you are chair of NEP for Standard 6 to 12 NCERT curriculum.
So what do you want me to say? Which of these things you want me to talk
about? What do you think is the current, curriculum is doing justice to what?
See, I think this is if you look at different curricula, not just school. For example, if you look at a curriculum I'm more familiar with, say the computer science curriculum, undergraduate curriculum, there's nothing wrong with the curriculum. The problem is the way it is taught, right? So the curriculum is often very, I would say, very vague about, there will be a list of topics with no clear idea that should you spend equal time on all of them or should you spend most of your time on this, as Jam was saying that, some things maybe you just want to introduce to give them a flavor that this is something important, but you can learn it later on. So I think the same thing happens in a different way at different levels. So I think that, of course, in the current context of what we saw about the NEP and the resulting things, there are some definite changes that people would like to have in terms of incorporating areas of mathematics which are not traditionally taught in mathematics. Some of the stuff which I alluded to in the morning talk about data and computation, we feel should be integrated with maths. But of course, if that goes in, then somebody has to go out. So there has to be some adjustment of content. But I think more than anything else, I think this also goes back to the previous discussion that we were having about who teaches the subject. I think it's not merely a case of whether the person from maths teaches it or whether the person from the subject area, application area teaches it. That both sides need to have an appreciation of the other side. And I think this is what we lack. I think people who are trained in maths think of mathematical objects in a very formal way, and they are almost taught to disregard any non-mathematical interpretation of what they. So it is very, in some sense, it's a very closed world. And for people who are using these mathematical tools in their domain, they see them as just tools, without any need to justify or understand what these things are actually, how they hold together, or any kind of questioning about why it works or why it does that. And I think, therefore, this is the difficulty. I think that you need an appreciation of both sides, and I think the people who teach are typically not trained to deliver content in that manner. So I think, I'm not sure how much even co-teaching will help unless the teachers are receptive to this. So as a case in point, for example, I teach algorithms on NPTEL and various other platforms, including this IIT Madras program. I have never studied algorithms in my life. Okay, I was in a generation which went through IIT Bombay, did computer science, in which algorithms were optional. And I think my understanding of algorithms has come in a sense operationally because of being also on the other side a mentor and coordinator for the Olympiad, Informatics Olympiad, which requires, so I learned my algorithms through training students for the Olympiad. And I think, therefore, I have a different, maybe, way of understanding and explaining algorithms from what a person who has been trained in algorithms does. So I'm not saying my understanding is better, but I think I'm able to communicate it better, possibly too. So I think that this is a difference. I think that, so sometimes the specialist is lost in their own kind of intricacies of their own subject, and they feel everything in this needs to be conveyed. They are not able to abstract out and say, if somebody doesn't understand this, it's okay, but as long as they understand this. So to draw that line between the essential and the kind of frills, I think that is harder for somebody who's immersed in the subject. So therefore, an outside person can do it better. But the outside person must know that there are these intricacies. They cannot just say, oh, this is just a mechanic. Going back to what Siddharth, you were saying, that you cannot just treat mathematics as a procedure which is to be applied. Right? So that's part of the problem. So now coming back to the NEP and NCF, so we are, just to update people in this room, so this NEP thing is being translated at the moment into a new set of books. Okay, so there is and that's why I'm advertised as the head of a committee. So we are trying to revise, not just in mathematics, but there is a move to revise all textbooks at all levels to align with some of the principles which the NEP has proposed. To what extent it will be successful will depend on, of course, how well the teachers who will deliver this material can be, updated about how to integrate. Because a lot of it is about, you see this word holistic and so on. So a lot of it is about each subject appreciating better how it connects to the other subjects. So this kind of compartmentalization, which was rightly pointed out as one of the difficulties even within mathematics, but across subjects also. So I think that this is a hard problem to solve, but I think we have to at least start optimistically that we will solve it and hope that we can supplement it. As you said, there are lots of other material, both for teachers and students, but primarily for teachers. I think these kind of preparing supplementary material in terms of videos and extra material is much easier now. So you can equip teachers much better to have different ways of addressing or explaining a topic compared to just one thing. So I'll stop there and see.
Yeah, I think we have around half an hour. I mean, I would like questions now from the audience. You can be specific. Just introduce yourself so that we know where you are coming from, and ask your question, maybe to a specific speaker or in general. Yeah.
I'll give this.
So, any questions? Please raise your hand. Yeah. question here.
No question. I will.
You got a second thought? Yeah, please. We have enough time.
I will ask. I will initiate that.
Yes. Yeah, somebody has to break that.
Just for curiosity, I'm asking because is there any provision to have the common mathematics and some specialized mathematics as it was earlier? If I am not wrong, that long back there was a provision like some common mathematics, because it is not compulsory that every student must learn mathematics at that extent, but the essential maths and then some rigorous, that is there any provision to provoke the students, young minds?
Yeah, so I think Jam is better positioned to answer, but I think experiments have, at least in Indian context, have shown that this is very difficult to implement in a fair way, because it ends up not leaving the choice to the student, but because the schools have to have resources to teach both sets, and there is usually priority, or even otherwise, if you're looking at only results, for example, then it's enough to teach the lower maths or the core maths and not offer the challenging maths. So that becomes a problem. So as was being also, I think Ulpa also referred to this, that if you address only the students at a sort of mean level, then you, at some sense, you do injustice to both sides, so you have to somehow balance it out. So in the current thing, what we are trying to do is to create some supplementary content within the books, which will allow students who are more advanced to explore things on their own. But I think there is of course, as you go higher up, maybe to, class 11, 12, there's a better case for having different levels of this, because there certainly, I agree that there's no reason why everybody who studies maths should be aspiring to study calculus at the level that you need for engineering exams. At the same time, to then say that everybody who doesn't do that should drop maths is exactly the wrong thing, because so many other disciplines need mathematics, social sciences need it all the time. And then to say that they have left maths as class 10 because it was not offered, in fact, that's a very sad state of affairs. So we need to address this, but I think having two levels, at least up to class 10, seems to be challenging operationally.
Yeah, any other question? Yeah.
I'll sit and ask the question because I have to, otherwise. The question is actually to the panel, so you can decide who answers it. I know that Ramanujam was part of the math 2005, and the underlying principle there, if I have understood it correctly, was that the child constructs her own understanding, right, of reality, her understanding of the subject. Is there such an underlying principle for this exercise, is the question which I would...
For NEP 2020.
For now NCF, which is now, being formulated under NEP 2020. Is there an underlying principle like that?
So, I mean, I don't think it has been articulated in such a crisp way. Certainly the constructivist thing, I think, continues. And therefore, I think the aim is to have, speaking from the context of mathematics specifically, is to actually have an explore and discover way of teaching. So I think that in that sense, it's a continuation of the philosophy. What has possibly changed is possibly the range of topics and what should be, maybe what makes way for what. But I don't think that there's any drastic change in terms of how, because I think everybody agrees that that's the only way to make it.
So you mean the learning by doing?
Yeah, so it's essentially learn not by giving somebody a procedure and saying execute it, but trying to, explain. Yeah, learning by doing is part of the thing, but also explain new things through examples and build it up bottom up in some to the extent possible. Of course, if you do everything that way, it's very slow. So has to be some up to a certain point you can motivate, then you have to present, but then also justify. I think that is something that we are trying to make sure, at least in middle school, that even if it is not, the distinction between a formal proof, which we hope later students will be able to articulate, but the distinction between the syntax of a proof versus understanding what constitutes an argument. So I think that is something which students should realize, that mathematics is not a kind of set of laws. Somebody say not a legal book. It's not a set of arbitrary decisions that people have made and that you have to memorize. Right? So they arise from a certain, initially from a certain need, obviously counting and measuring and all that. But then other things arise, operations arise from a need for doing things efficiently. And then certain things are maybe, you can ask, why should exponent half be square root, right? And things like that. So then you need to, sometimes it's just internal consistency. You need half plus half equal to 1. I mean, so you want that. Right? So these are things that you can justify. And even as we were saying, division, why does division work? I mean, so all these things, I think, if you need not justify everything, but if you have the spirit that everything that is taught is justifiable, and some of the things you justify, I think that already is a good step, I think.
So as it was pointed out that yes, students have its own way of understanding things. I would request, while designing the textbook, wherever possible, everywhere not possible, but wherever possible, at the end of each chapter, if they can give the application of that concept, just mention the application. For example, I would say like polynomials is used in the bridge construction. How? To what extent? Let the child explore on its own. Whoever is interested will definitely Google for himself or herself to find out, is the statement true? And if it is, to what extent that there is an application. Wherever possible, I would sincerely say this should be done to whatever extent can be done.
So NEP emphasizes the shift from teaching to learning. Excuse me. So NEP emphasizes the shift from teaching to learning. So what impact does it have on the current practice of teachers rushing to complete the portion? That's one. The second thing is, by putting the emphasis on learning, it's definitely now outcome based. So are the new textbooks being written to measure the outcome of the majority? Or, okay, I think that's enough. It's an open-ended question.
I've seen, I just, watched a video of, when they were announcing. They are saying that in NEP 2020, they want to shift from outcome-based to competency-based.
Oh, wow.
So it's one level up. So I don't know, how this is going to get measured, but I mean, that is the statement there. From outcome based, just not outcome. I mean, outcome would be that you know how to apply a formula, given the length and breadth, how to compute the area. But are you given us some kind of a object? Can I estimate what is the area of this? It goes a little beyond just knowing the formula. So I don't know how that will be tested. Right? I mean, some kind of an estimation. I mean,
President already started the improvement of mathematics and sciences. The process is going on still now in the United States.
Okay.
They are making mistakes, but we can learn from them. That's what I'm saying.
But I don't know what a competency based.
1962, they started that process.
I see. Yes.
Billions of dollars they have put, and the process is going on. It's ongoing.
No, I think these activities are going to be ongoing. I mean,
because we will find out some of the shortcomings in the earlier one, and then we will try and improve upon.
Okay, cash on their experience.
I see. But I don't know, anybody want to say something about this competency-based evaluation and
Yeah, so I talked about it in the morning. I think designing assessment is the hardest thing. And I also agree with you that it is very difficult to suddenly think about all these, because obviously you also need to test competency. Let's see, everything has to be balanced. There are many constraints. There is time constraint, right? And you cannot also not teach certain, say you're in middle school, you cannot not teach fractions and decimals and percentages and certain things, right? So there is a certain amount of core content which you cannot skip. Therefore, if you do everything in a kind of bottom-up activity-based way, you will not have time to do everything. You have to teach some things kind of by giving the fact. And the other thing is that you do have to ultimately, these are things, some of the things at least that you do have to do often enough that you get some muscle memory, mental muscle memory. You cannot play tennis if you have not hit 1,000 forehands, right? Yeah. So you can't proceed if every time you have to go back to first principles and say, oh, multiplication is repeated addition, and it's not going to work. So there has to be some outcome-based understanding of procedures. So I think when you say competency-based evaluation, it can only be a smallish component. I don't think you can have a completely competency-based evaluation of any subject in a realistic sense. So we have to try and keep all these things in our mind, but live with some, live with the reality that we'll have to balance out how much new things we can do. And also the other part is to get teachers and other people who are going to deliver this material to be comfortable with it so that they are not completely at sea as to what's going on.
Yeah, you want to say something?
Yeah, so there are two things actually. One is the scare that, with NAS and everything happening at state level, there is a tendency from the state to, teach to the test. So that is one scare. The other scare is, on the one hand, NEP talks about local contextualization and all that. And then you have these outcome-based things which standardize everything for everyone. They are basically conflicting views present in the same document. I just want to place that. I don't know. I don't have a solution for it. But
so to the test means, it's like giving.
It's basically there is.
No, even otherwise. So this has been from whatever we have heard from the teachers who are, so the curriculum committee has people like us, and then it has, of course, people who are educators, more professional education research people, HVACSE type of people, and it also has teachers who teach. But a lot of the teachers who teach say that this is the normal problem, that at some point you have to switch to teaching for the exam, because that is how the outcome of the school and the teacher and the students and all are measured. So if you have the test, the standardized tests as the objective measure of performance, then there is a natural tendency that teachers will be under pressure to teach students to prepare for that test. And that test, because it is standardized, will have some standardized format. It will not be a competency-based, open-ended thing which people have to think. So there will be a natural tendency to do that. And to what extent you can overcome that is something that, it's a social problem in some sense. So I don't know how you can actually have something and not make people teach towards it. It's very difficult.
Yeah. So I would like to say something on this more as a MTA person, so to speak. Since this is a MTA conference, I want to emphasize that. Not so much for, curriculum committees and NEP education policy documents and syllabus committees and these. I've also been rattling around in these spaces. But I think when it comes to this particular thing that we are talking about, I find that there is tremendous lack of clarity at all levels. And I think this is very important, especially in mathematics education, to take seriously. Earlier Vivek was asking about NCF 2005 having a constructivist core. as a principle around which things are identified. Now, if you read the NEP 2020 document and the NCF 2023 document, one problem is that, of course, there is talk of learning by doing and so on, but they are in a kind of an instrumentalist way, right? You need this to achieve something. That's not as a principle in itself. And that's okay. I mean, it can be a different articulation. I have no problem with that. But there is this lack of clarity, as he's pointing out, when you talk about outcome-based, competency-based. And there is also a big problem about, there are some things that happen on a mass scale, right? Mass scale testing, like we talk about National Achievement Survey, right? That's a mass scale sample-based testing that happens in a particular way. Board exams give data that happen for every single student across the country. That happens in a different way. Classroom assessment is very different. School exams are very different. We treat them all as the same. And I think this is a fundamental problem, and that has nothing to do with governments and society. I think we, as teaching community, must take responsibility for this in our own spaces. I think this is very important because personally, I feel that when we talk about assessment, I mean, Mathan also made this, right? I mean, this is a very different thing. I mean, on curriculum, on mathematics content, we've had centuries of thought, right? On pedagogy, there is a lot of thought. I mean, we are doing a lot. Even in whatever spaces we have got, our own, we have workshops, we conduct these things. On assessment, I mean, he said 1962 they are working and so on. I don't know. I've seen the US thing also. I feel we are not even at the dawn. I think we are at the dark night. This is at least my angst. Because we talk about these problems of assessment. I'm talking about specifically mathematics assessment because unlike many other, when you talk to science teachers, language teachers, social studies teachers, assessment is a problem everywhere. Madhavan was talking about it in the case of data. Everywhere it's a problem. But it doesn't lead to the kind of tears and shattering of self-confidence and self-esteem that maths assessment seems to do. Especially it's, in my opinion, at higher secondary level, undergraduate level, early undergraduate level, or secondary, higher secondary level. These are all teenagers. This is the time they're going through emotional problems and you're hitting them with a whole lot of stuff they feel terribly, out of, right? So we are talking about something that very clearly has psychological implications on a very large scale, right? So I do think we have to take it very seriously. And I think we should look at it. Why should class 7 or class 9 September exam look like a board exam? That's what we do, right? And from the science movement that I've been part of, Tamil Nadu Science Forum, we have conducted many workshops where we actually sit with teachers and just look at, take a learning unit and do different models, different assessment models, problems. The thing is, it's very hard for us to design problems that are very different from end of chapter exercises, right? We've all got so used to doing precisely that it's very hard for us to even come up with ways by which we can bring in many such different processes. I think in terms of even having databases, I would say that as Teachers Association, one of the things that we can do, of course, we should do tech tools, use of that, change classrooms. We should do Olympiad problems, or we should do all of that. I hope we can build a community of people who come up with hundreds of alternate assessment models. Let's put them out, right, for teachers to use in their classrooms. I agree, board exams are different. See, mass examinations come with certain challenges. There's only so much you can do. I mean, Madhavan was talking about online, right? There's only so much you can do. But in classroom where we are sitting with children, surely we can try various things. Can we find schools to give some freedom? I mean, several people here have responsibilities as administrators in school as well. A lot of experience that, they're not just maths teachers. There's a lot of administrative experience as well. How do we bring in alternate modes of assessment in our classrooms? Can we develop a bank for teaching specific topics, specific units, right? And maybe different, why should there be one, right? That's also very silly. In a country that is as diverse as India, I would expect 100 models. We don't have. The truth is we don't have. Right? So it's not so much committees that have to blame in these things, but as a community, we don't have enough clarity on mathematics assessment, something that is non-punitive, something that supports students in their learning, and yet, achieve the kind of whatever, I don't know about outcome based, competency based, new jargon keeps coming, but something that is to the core of mathematical thinking in the classrooms, right? Whatever based it is, but I think this is status quo is something that we should definitely not accept. At least that much we should start with, saying that, we should not wait for all sorts of people to change things before we change some assessment models, right? So I would say this is a plea, for the association also to take up and do.
Yeah.
Hello. Yeah. Good afternoon, everyone. First of all, one thing I want to add to this discussion is we talked about being honest and saying to students that we made mistakes. I think for all mathematics teachers, and this is from my personal experience, if we tell them it's okay, it's our mistake, and after that, if we tell them how do we identify these mistakes and make this correctly, that would really give a good impact. Like students will identify, suppose there is a question on permutation combination, and we find out that the answer was 960, and I'm getting 1260. So some things I have counted extra. So let us identify what I have done. So if we do that, if we inculcate the same thing in our assignments, that would give a good impact and the logical, analytical ability for the students. This is an add-on thing. The question, sir, which I want to ask is, all the teachers, generally, we are all from 9, 10, 6, 7, 11, 12, all the other standards. The ground reality for execution, curriculum and all, as you said, it's a part of different, it's a different thing. When it comes to the execution of this, there is also an output based and also competent based. So output based, basically when we think we have a certain time limit, then we have to complete the courses and we have to appear the students for the examination. In that, one thing I want we people to discuss among ourselves. Pedagogical side, there are students who learn the concept by identifying the patterns and solving easy questions line by line. There is a concept that you give them just numbers I am giving just to identify the scale. You give them 50-60 problems on the same concept. They'll solve the questions and then they identify pattern and they learn by themselves. And the other thing is, you give only 10 easy questions, let them spend time on 5-6 tough problems, and while they invest their time in those 5-6 tough problems, they learn a lot. I want to understand about the mediocre students. For the top class students, it's okay. You give 5 examples, you give 5 good questions, very tough questions, they learn a lot. When we are talking about mass, at that time, for mediocre students, what should be the strategy to balance and, of course, the output-based learning? Thank you.
So his question is, the top and the bottom, there are different issues, but the mask is in the middle. And what kind of strategy will work, will motivate them to
I think a teacher teaches to be average student. So he neglects lower bottom as well as the top students. Especially top students get disillusioned because the teacher is going very slow. It's very difficult exercise. It's a very difficult exercise to manage the classroom. And if there are 60-70 students in a class, then it's very difficult. So the number of students in the class should be less. But still this problem persists, that the top students get neglected. So he has to find avenues to learn and satisfy his need from outside. The teacher is not in position to do that. In a classroom, I'm talking about. Outside the classroom, perhaps.
So my only contention is that when you call them mediocre, you are calling them mediocre according to the test that we design at the moment.
by the interaction, the capabilities, thinking capabilities of
which is subject to you and the classroom, right? So we have, just like sir said, there are lack of assessment methods for us to, it's basically that when I was talking, I told you about examples of how you do tables in the classes. So in one language they would do 2 3s, in the other language they would do 3 2s. So sometimes just the language is a barrier. So this is you asked a very general or generic question.
basic question.
Yeah. So it would change from person to person. So for example, there are kids in certain classes where they didn't know math, they knew art. So I said, explain them with a drawing. Explain what's happening. Maybe you can sit with this child who knows and do it. So maybe he's gotten to some place from there, from wherever he is, right? So the problem arises when we teach to the test and we want them to perform well in a test. If that is not the criteria, then maybe this question is will not arise, right? After, yeah, I understand completely where you're coming from, and these are real challenges in the school. Yeah, I agree. Yeah.
Still any good solution for this?
Yeah, so
The mic is.
So I want to go back to the question of assessment. Just ask a question, and there's some comments I have. Maybe we can make. I can say that afterwards. So this is regard to what Madhavan was saying in the morning, which is very interesting because it's an open system. So they don't have any barriers or any selection filters, right? So kids come in. But there is indeed a barrier, a selection, but it happens only after, I don't know, one semester or the first unit test or something like that. I don't remember that. So the question is that if you look at the selection criteria which is used, which is the performance in the unit test, is it correlating with something like school marks or what does it correlate with? I mean, if we use this as a filter, then what is it really testing? Could you shed some light on that?
So the programs are easy to get in, but getting out will have to have.
Yeah, so here, I mean, not sure.
So I don't think there has been any. I personally, I don't think there is any correlation, but I don't think it has been studied. So I'm just saying this off the top of my head. But yeah, so the idea is that so there are several things in this. So one thing is that there is no limit. So students who do not do well in this can do it again. So that is another interesting question, right? So you do the same material again because the material doesn't change. It's the same first 4 weeks, right? And if you don't pass the second time, then what does it say? So the fact, first of all, that there is a fairly large attrition. I said my estimate is 25% survive. So 75% of the students who come in, and this is not in absolute terms a very difficult test, and the cutoff is 50%. It's not even like some high threshold. So there is part of it could be aptitude, part of it could be application in the sense that you have to actually sit and do these things systematically on your own, and maybe not all students have that drive or motivation to follow 4 subjects. So I don't know, there are many factors to it, but I have a feeling it is not
mathematical, logical quizzes.
correlation to entry level marks as such. But this is something I can ask them to check. I'm sure if it had been, so I believe it's not.
People don't want to. So then, can I just make a follow-up comment? Because see, the issue of assessment is a much larger issue. We know that it, in fact, sheds its shadow. It shapes the curriculum in some sense. But the assessment is subject to social pressure. I mean, Vivek asked this question, what is the underlying principle? We can talk about it in terms of the internal curricular or pedagogical principle, but there is a much larger principle operating with respect to education as a whole, which is enormous aspirations and extremely few opportunities. I mean, this is the underlying principle of our education system. Therefore, we have stringent selection criteria, filters, which everybody aspires to go through and succeed. And because of this, what we're doing is we're over-assessing. We're assessing too much because we want to filter out as many people as possible. So over-assessment is the guiding principle of our education. And because of over-assessment, over-curriculum, over-teaching, teaching too much and having too much in the curriculum, at least in the sense of, getting kids to practice, do things again and again, to become, extremely quick response by identifying. So all this is a feature of our education system, and the only thing that can disrupt it is, I think, experiments of this kind, where we let in students and just check whether they know enough to really carry forward in the program and pass it. So maybe new technologies, new systems will create more opportunities, open out that narrow thing, and bring about a change in the system. Otherwise, I think it's just a structural feature, and it's not possible to fix it by making adjustments in the curriculum or assessment, I think.
I would just like to add to this, as it is said that the assessment is competency based. Okay, while doing so, no, there are many coaching classes which are right now come up. Some of the tricks which were being applied by the teachers in the classroom for understanding the concept easily. Okay, as in the morning said by Siddharaj, like adjacent angle, right, cannot be said like this. Why adjacent angle has to be taught like this? Like parallel lines, transversal crossing it, corresponding interior edges, angles, and all these concepts. Why it cannot be expressed in the terms of acute angles and obtuse angle? Yes, explain them, give them all the tricks possible so as to understand, but don't lose the essence of mathematics while doing so. For example, in engineering colleges, they can use scientific calculators. Today, scientific calculators are so designed, you can calculate eigenvalues, eigenvectors straight away on the calculator. Teach them. But at the same time, at least one problem should be done for them to understand what is the procedure in doing so. Why I personally believe in that, because the standard methods has to be made, students should be made aware of those methods, because as I said, I strongly believe in it. Students' visualization is far ahead than what we can think. There may be one among the 100 who come up with a new method or new technology or new software for calculating the same thing, which is not even into existence. The child can come up or reach to that point only if he knows the standard method. This was the way it was done. Like even solving the system of equation can be done on a calculator. That is what we imply, because as per the syllabus, that is allowed. But solve at least one equation, what you can say, a cubic equation, how it can be solved using trial and error method, then solving the quadratic equation. Do it on the calculator, but teach at least one problem only for the child to be aware of it. I feel so.
So this is not a question. It's about yesterday also somebody was asking about differentiation, integration, and he is also asking about this kind of thing. So what has worked for me in these many years for in prop stats and calculus and those topics, what I do is there are two different level. One is writing, one is solving. So students have problems. Some students keep on saying that they know how to go about it, but they don't know how to write it. So we need to understand that these two problems are separate ones with different solutions. So there are students who don't know how to go about it. What you do is you keep on, first few problems you keep on thinking with them. So you tell them how you are starting, how you are figuring out. It may not work for everything, but it works for most things. And you will see that after one or two problems, they start thinking with you. That's one. And second thing, you tell them to write the solution and evaluate your solution after a week, because when their memory is not so fresh, and that somehow help most of the students, if not all. But then there is this third point, which third point is there is this new fashion of not remembering anything. So you have to keep on telling them that these topics. So there are 6 methods. Let's say in integration. So you think of these 6 methods as 6 people that are there in your life, and you need to know their names and you need to know where they live. And then when somebody is coming to you, you need to know who am I talking to. So So there's this new trend that, I don't remember almost what I'll do everything. Because, this old tradition of remembering thousands of lines is useless. So you need to tell them that that was useless, okay, I accept. But that doesn't mean that you don't remember anything. So what I feel is sometimes when you talk about a problem, there are many smaller problems within that problem. So you start addressing them separately, and most of the times you see that students come to you and they say that, okay, I understood, now this problem is resolved, but then I see that there is next problem which I am unable to. By problem, I don't mean mathematics problem, about learning or writing or some such problem. So I mean, most of you are more experienced than me, but this is something that could be, yeah. I thought I'll just share. Thanks.
It's almost 1:30. But yeah.
Sure.
I just wanted to say about assessment. As it is said today, that the assessment that we follow with regard to the students is we assess the rote memory of the students. So when the students answer the exam, rather than checking how much they know or their intelligence, we most of the time check how much they can reproduce what they have memorized. So we check on the memory of the students. So rather than having the rigid assessment pattern, can it happen that we can assess the students when any concept is taught? The assessment could be held like how Ulpa said, the students can be divided into groups, and when first the teacher explains the concept, and the concept could be assessed in groups, and the ones who solve the basic examples could be given the little bit of difficult examples. As they solve, more and more difficult examples could be given, provided there is a boundary that is set for which how much difficult problem can be given for a particular class, and how much time could be spent by the teacher for that particular problem in the time frame of the curriculum. So as per that, we assess the students, and because as per what I feel is, when we assess any of the students, it's not instead of allowing the students to basically, it is seen that the ones who are more intelligent are the ones they make silly mistakes in the exam in the present scenario. But if they are given freedom, I feel they will come up with a better way. So in this present scenario, those type of students are made to lose their confidence compared to what the ones who have better memory.
Thank you. Point you're making is, I liked yesterday what Vivek said, that many times our test reveals what the students don't know than what they know. Yeah, I mean, what they know sometimes is much easier, but what they don't know. Yeah, so that's our tests of an undertaking. Any other questions? Yeah, there is.
Just only one comment.
Yeah.
Sir. They are supposed to know certain things. That is to ignore. They are at a particular level. They are supposed to know some basic things. If they do not know, then that's a problem.
I do agree. I mean, that is most expected. I mean, like for example, I saw that in NEP they have given a lot of emphasis at level 3, level 2, 3rd standard. They're saying that if they don't have a certain literacy and numeracy skill at that level, then they will suffer a lot as they go up higher.
That's what is happening.
That's a kind of a filter.
But that's also because the content also gets rigorous after a point. You introduce negative numbers. So we have not tested it without a different content, like for a different content, right? Like, is it?
So,
yes.
I would like to this one thing which came from the audience. What do you do for the mediocre? Basically, the strategy which is applied in the class is based on the mediocre only, so that we can tackle the slow learners also. And as sir rightly pointed out, the advanced learners get ignored. This is more of a conclusive or a suggestion from my side to tackle the advanced learners along with the some mediocres who are going towards the advanced learners. I would say this flipped classroom concept works. Now, what is a flipped classroom? Within the curriculum, take up a small topic which is easy for a child to understand as a self-study. Give the topic to the child, let the child take up a class. Okay. After that, you can follow up with the topic, whatever the child missed out in taking that particular class. That really helps. Flip classroom have helped a lot with respect to my engineering concept, engineering experience, engineering college experience. Second thing which I would like to add to this is a suggestion, or you can say appeal from my side. We should have more gatherings like this, wherein people from across what you can say, sectors coming together, maybe from school level, high secondary, or from college, or even from the technical college sections. Why? While designing or framing things, until we have interaction, I cannot tell as a technical institute teacher, I cannot, the high secondary teacher, I cannot convey to the high secondary teacher, yes, these are the difficulties faced by me. So, can you do something for tackling this at the high secondary? A high secondary teacher can tell a school teacher that these are the difficulties faced by me at the high secondary level. Can you help me with this, setting up the foundation at the school level? It may be designing, it may be in the form of conference, seminar, and which I've really not come across is having seminars, maths teachers. It's mostly how science exhibition, science competition, science seminar, science conference. But if you actually go and see over there the models or even the exhibitions or whatever is done, it is basically maths, Pythagorean theorem. Why can't we have at least once in a year, or maybe once in 2 years, have the best? Quality matters, not the quantity. That I strongly believe. Have something best. Why can't we have Ganit Mela, wherein we have experiments where students get hands-on? It is not basically display, where students can try out and learn things. I have seen this concept outside Goa, heard about it. Within Goa, I have not come. Maybe I'm mistaken, but I have not come something like that.
College, or Sakri College organizes mathematics every year.
Okay, so I feel this should be brought to limelight, and more people should be encouraged to participate in activities like this.
Community, I mean, if there is some exchange of ideas and communication, I think we'll be able to do that. There is one question, and maybe,
Good afternoon, everyone. Like with regards to assessment and how we, mark the students, I think we are more focused on what is the end result of that entire problem. And even when you are giving the marking, like when I go for board corrections and the assessment, the scheme is given to us, the answer key, like everywhere the entire problem is solved, the marking scheme is almost the same, the marks that are assigned to a particular step that is done. And finally, I think we should lower the marks as much as possible at the end result, because if students are more oriented, like, what is my answer, and a problem is solved in a class, they're like, okay, so I got this as the answer. Is it right? But the child is not able to, be sure that, yeah, what I have done is correct. They want a teacher's validation to tell them that, yes, this is the right answer, because we are focusing more on just the final answer. Like if it is like 32.56, if they have got 5.5, they will be more tensed up. Why didn't I not get that 5.6, and why is it 5.5? So when we are correcting the entire papers and things, that should also be taken care. Secondly, the level 1 and level 2 that Goa board has, end of the Goa board exam, the level 2 student also can go and take up science, and level 1 student also has, so sometimes students choose a easier path just to clear that one step, because they don't have a long-term vision of the examination, and they'll end up going in in science, taking science, or like we could give them the like the papers can be such that a particular when you are choosing students for your engineering or higher secondary, that level 1 a particular content is designed and percentage of that will decide whether the child will be enrolled for science or should not be enrolled, because everyone is not born to be a mathematician, and some students just answer for just to clear the exam. So that is my thought on with regards to this.
I have seen in the university, for example, somebody who opts physics at a BSc level has dropped maths at 12th. This is ridiculous.
Yeah.
I think these kind of things
This
were
is
not
allowed. So,
allowed.
unfortunately, it's allowed.
That's what, and this is all because of workload distribution among the faculty members. To understand, where we have reached. In order to balance the workload of the teachers, we are trying to say that these students should be allowed. Otherwise, my workload comes up and I'm declared as a surplus. So this is something that I think. So the subject combination for I strongly feel if somebody has taken physics, computer science, or statistics, or to some extent chemistry. I'm not sure about chemistry, but physics, maths, and computer science, mathematics should be there.
But
it may not be vice versa. Somebody who takes maths may not take physics, but somebody who takes physics should take maths. I think that should be.
So Goa is not allowing that, by the way. This year,
Yeah,
Goa has chosen physics with geology for BSc. They are giving computer science and math. So they have fixed it.
BSc mathematics may not be available because you can have combinations of mathematics. But in principle, if you read the NP clearly says that you cannot have this kind of requirements. Even for in principle, even for basic mathematics, you cannot insist that you are taking mathematics because you can take combinations of various kinds that make it possible to
They have prepared buckets under anything. You cannot make those choices and give those combinations which are not. It's not possible at all.
Yes, just okay.
Hello. Yeah, I think we have to be more careful about the use of words like advanced students and mediocre students. Okay. I mean, who are we assessing? Supposing we change the whole, the whole format and said that the teacher will be assessed by the average mark that classroom achieves. Okay, exam is given, the same exam is given, but the whole mode of assessment is changed and the teacher is going to be assessed for the average mark that class has achieved. I think that will be a game changer. Okay.
So I would like to add to it, that is what we follow in technical institution. Basically, we have something called as feedback system. Okay, based on the feedback and the class performance, a teacher's appraisal is being fixed at the end of the year. So yes, we to some extent we use it. Even to one more question, what the sir said over here regarding the final answer, we don't go as per that. At least I motivate my students by saying this is a beauty of maths. You get marks for steps. Procedure is more important than the final answer. I personally believe one problem can be done in 100 ways. Point is which method you select. That matters based on the weightage of marks.
Somebody also says that, right? I mean, step by step, gain marks.
So, but at times what happens while following the procedure also, they go wrong, but procedure is correct. Maybe some elementary mistake, but procedure is correct. I feel that should be counted. The child understood the procedure.
There is teacher appraisal, but never teacher appraisal.
Yeah, it's almost 1:45, and I think let's end this session.
I will take only 1 minute.
Yeah.
In Goa University, there is appraisal of the teachers. Unfortunately, it is not checked. It is just put in the godown.
Yeah.
I'm very blunt about it.
Yeah, I think many places the appraisal is not taken seriously. I mean, okay. I think it's 1:45.
So I'll just add to it. Yes.
Your teacher appraisal is checked.
Yes. It is checked every year because that decides increment in some of the colleges, even though it's a contract. For contract faculties, it matters a lot, sir. Okay? Yes, and it is a private sector college. One more thing I would like to add, like, no, for people, they say maths is difficult. I strongly believe in this one quote in Konkani we have, "Dade round pyong shikna." You have to get inside the waters. You cannot stand at the bank of waters and say like, I cannot swim. Same thing implies to all the people who say like maths is difficult. Get going, start, some point start. Motivate your, this should be like, no, we should be like the facilitators. Ignite the first spark. You need not ignite the fire. Ignite the spark. That's enough for the child to go ahead. Thank you.
Okay, I think we have enough for our thoughts, right? I mean, enough food for our thoughts. So let's go and have our lunch. We will meet again at 3 o'clock. Okay, but we are meeting for the next section, right? There is a feedback session. So that's at 3 o'clock.
So we can have it
Early.
have it at 2:30.
So it's 1:45. So 2:30 we will meet here. We have
A few announcements which we are going to make. Just please. You're going to
No, there is one small ceremony that is remaining.
Yeah, that we will finish. And we want to take a photograph of all the participants that we missed out yesterday. So we'll finish with that. So please be seated, just wait for another 5 minutes and then we'll disperse.
So on behalf of the conference committee, we have a small memento to all the panelists who are here. So I will request the director to give a memento to each of them. So we'll start with Sir Madhavan. Thank you, sir. Then Professor Ramanujan. Professor S.U. Kamal.
Thank you.
Siddharaj Walker. And Ulpa Wyman. Thank you for accepting our invitation at the last minute and having a meeting with you on the panel. Okay, thank you. Your announcements.
Yeah. That's the only thing we will take. Please be seated, we will take a photograph of the space. You can join us. No, it's just all, everyone. You all have to just be seated.
This way or?
No, this way. We usually take the other side because yeah, this goes everyone.
Yeah. Hold up.
Thank you. So one photograph of the. No, we'll stand here.
Hello, hello, hello.
Yeah, welcome everyone to the concluding session of the regional conference. Thanks very much for all the wonderful interactions we have had. So let me invite Professor Subramaniam to talk a few words about the activities of the association and where we are hoping there will be extensive participation from Goa as well. And the Western region.
Thank you. So, should I say something about our session also? Yeah. So this is a sort of, before I say something about MTA, I'll also share how we have structured this session. It's a very informal kind of structuring. So one of the purposes of this session is to, can you hear me? Sir? One of the purposes of this session is to get some feedback from you. So please feel free to share your thoughts, your reactions, etc. about the conference. It will help us also get an idea whether we're going in the right direction. What are the things that you appreciate? So that will be useful. What are the things that you might have liked but which is not there in this conference? That's another aspect you can mention. And finally and importantly, how you would like to take some of these ideas or some of these thoughts, suggestions, etc. forward. Maybe in your own work, but more importantly, in terms of, say, continuing the activities of the association, using the association as a platform, what can be done. It can just be a sharing of ideas, then we'll see how it can actually be implemented. So this is one part. I don't know whether we should start with that and then talk about MTA. I think that's, yeah, maybe we can start with that, having some feedback from you, some reaction.
We are also asking for a formal feedback. Okay, Vandana. So formal feedback, I think, is available on the QR code. Okay, you can scan it and get the form, and you can give a feedback. Okay, and Vandana has made it little challenging that unless you give your feedback, you don't get your certificate. So it is linked to your certificate, which will be mailed to you. Right? I mean, we have made sure that.
Once they fill within 24 hours.
Oh, so she's also giving you upper bound. Within 24 hours, you will get your certificate as soon as you submit the form. So please scan the code and do that job. So we are looking forward for a feedback. I mean, please suggest so that this will help us to improve upon. I mean, we know that there have been some issues that we couldn't manage. The call for abstract was very short. That was our problem because we couldn't decide on the dates. But
as a result, I was told that that's why I think nothing came from Gujarat because they didn't receive it in time. But maybe this will take care in the future. Yeah.
So maybe I can begin with the question. So this conference, as you know, is for 2 days, right? In fact, not even 2 full days, because we'll be winding up after this session. So what do you feel about this? Should conferences of this sort be longer, or this 2 days works for you well? Yeah.
So yesterday's this workshop. So yesterday's workshop, there were many interesting activities which we could have learned more about it. Maybe 2 sessions, like one yesterday, one today. We could have stayed back and had one more session about the workshop. I mean, the mind reader game and other games. We could have had maybe one more session of. That's what I thought.
So, yeah, just adding to the same thing ma'am said, we did the sessions, but maybe if there could have been facilitation of, what questions could be asked after that sort of activity, so that, there is more learning in which directions we could take those things, because that all the activities were very dense. You could do many things with that, but what's the next step, in how many different ways we could take those activities. I think because of the time constraint, just the activities were shown, but if there is some facilitation to get questions or something, yeah.
But holding it in parallel,
That-
price,
Also that, yeah.
You have
Also that, yeah.
I did 50%. I think that. Yeah, anybody else? Yeah.
I think you put up your hand again. Mike.
Hello. So my opinion on this today event, it was a wonderful gathering that we had, some deep, insightful thoughts, especially by Professor Ramanujam about multiple assessment models, wherein we could work out by stretching our efforts inside the classrooms as well by trialing something. And the second thing is Professor Muhund about our preparedness on computational thinking. That was very insightful, which I would like to take it back as a message. And regarding the suggestions that we could further extend is that those parallel sessions, which both of it are equal weightage, but we are made in a position to choose only one among that. Because being in now I am in high school, so for me both lab exercise as well as computational thinking both remains to be an important priority. So if the participants are allowed to choose a bit earlier with the varied choices, which could favor every participant to benefit out of the event. Thank you.
So we've heard a little bit about the workshops and the keynote talks. Any reactions to the paper presentation sessions or the poster sessions? Somebody would like to say something? Because the paper sessions were also in parallel, so that we could accommodate more paper presentations. So is that the right thing to have? Because if you have a plenary for papers, then there will be fewer papers which can be presented.
Do you think that some assistants could have helped you in writing the abstract? Huh? You had an idea, but maybe you have no experience in writing it up in that format, in the form of an abstract. That's where you face difficulty and hence you did not submit. Do you think that an assistance like this might be of help?
Yeah.
So can you be more specific? What way? See, the idea has to be yours. Somebody can help you to, polish it a little here and there.
Yeah, actually, when I first received that link with regards to writing the abstract, I was so enthusiastic like to do it, but then there was a problem like how to go about with it, because the way how we have a lot of thoughts in our mind, but then to put it in a form that everyone understands is difficult, because it's a text that you're putting, you're not explaining it to someone. So maybe a session on that could have helped us to make a better write up and submit. Also, the links and all that we received was very late, and then the time frame to work on them was was not enough. So it was in a point like either you submit something just like that, or you plan and then not submit, and next time maybe you could work on something like that. So this time, that's why I personally took a point like, okay, let me just see what exactly it is and then work around with it next time. Thank you.
Thank you. I think that's very useful. So the time, that lead time that we give is important, and also maybe, like you say, after one or two conferences, then more people get an idea of what. So in this connection, I'd just like to mention that previous conferences, we have had mainly online conference, because like I said, soon after the association started, there was the COVID lockdown. But the online conferences we had, 3 annual conferences, the videos are all online. So I'd invite you to see them. MTA has a YouTube channel, and you can visit the channel. You can see the recordings of the plenary talks, even the workshops which were conducted in the annual conference, as well as, I think, paper presentations. So you're welcome to visit those and see those. Any other reactions people would like to share? Okay, so maybe I'll say something about, yeah.
Yes, I would like to add about the paper presentations. At least the paper presentation section which I attended in this hall, they were really good. Okay, so, especially the one which made an impact for me was incorporating humor in the class in the different forms where you teach. Okay, that was one thing. Even the others were really good, incorporating the city skills wherever possible in the class. But yes, as sir said, I could not attend the other side. I don't know what was the content over there, or I feel like maybe something of for me also was there in the other section wherein I was deprived, because both were going in a parallel. As sir said, maybe that is one clause that more papers were supposed to be incorporated. That is why parallel sessions were held. But and second thing I would like to add is have at least one conference, a seminar, or something wherein people know how to write papers in maths. Even as coming from the technical education side, I also lack that skill of writing papers. I would really love someone taking up something session like that. Even maybe online also it might help. There are, I'm not saying there are not, there are even what you can say in the form of books also there are, but something wherein a session like that is held and at the spot at least an abstract participant can write up to that level, it would make a huge difference. And second thing, just a suggestion from my side, since it was NEP and curriculum, I felt I was expecting like people would speak about how NEP affected their sector, which I found was somewhere missing. I wanted people to speak about 4 plus 3 or 5 plus 3 plus 3 4, correct? 5 5 3 3 4. So I wanted to people to speak about that. I was expecting or was looking out for that, you can say. So I felt that was somewhere missing. Otherwise, overall arrangement, the papers, the posters, yes, they were very informative because after a long time I attended something like this. So I'm looking forward for the upcoming events by the MTA. Thank you.
So, do you want to elaborate a little bit on that? What you said about NEP, what your expectation was at stages?
How NEP affected the curriculum in different sectors. I was looking forth for that part, like maybe in schools, maybe from 8th, 9th, 10th, high secondary sector, or maybe even college sector, like how it affected to what, good, bad, whatever.
Okay, so that needs to be discussed further.
Because I feel by the time NEP is put into force, like no activated, at least it will take 2-3 years for the things to concretize and like okay fine, this is the framework we are going ahead with. But till then, those batches which pass out, they will be on the trial base. Why I feel this personally, because I noticed during the COVID times, coming from the technical education side, the batches which passed out in the COVID, no company was ready to what you can say, hire them, saying like you are the COVID batches. Then the law was passed wherein no company could put that no COVID batches allowed. Okay, they could be taken to the court, and that is when they actually select them based on the certain procedures which was done usually. So I felt that should not happen to this NEP passing this trial batches. I would say trial batches because they'll be the first batches wherein they'll be going through this procedure. So what can be done for those batches so that they don't lose out anything? That is what my concern is.
Thank you. I think that's a very important point and the right sort of thing to discuss in this forum. So we could take that up. Any other?
NEP says that we have to conduct a lot of activities. It should be most activity based in mathematics or other subjects also. But in mathematics, most should be activity based. But so for primary level up to 5th, 6th, we can conduct activity. But when we go to higher level, conducting for one topic 4 activities, it's not possible. But NEP says that the school says no, and this is told by NEP. No, you have to conduct activities and many activities. But then how to go about the syllabus? We have to complete the syllabus also. That is the only one point. So at least make it clear how many activities per chapter in a month. Is it 4 activities or 5 activities? Because that has been told by school. No, you have to conduct activities. But then portion is there, syllabus, then exams. How to go about it? Thank you.
Yeah, I think that's very useful. How activities should be incorporated at the maybe middle school and higher levels, secondary level. Yeah, okay. Thank you. Okay, so let me say something about MTA. As I said, it was started in 2018 and we had the first annual conference in 2019. In fact, it was on the day which commemorates the birth anniversary of Savitribai Phule. So we had the first conference. Of course, after that, we were forced to hold conferences online. And so that continued for 3 years. So we had up to 2022, we had annual conferences online. They were also, I mean, the structure is somewhat similar to this conference, but typically it would be for 2 or 3 days. depending on the conference. And we had keynote talks. Usually we would have, I think, 3 keynote talks. Typically, we choose 2 from mathematics education and 1 from mathematics, which is interesting. Those videos are there. We have had some excellent talks, both on maths education and from mathematicians, leading mathematicians who are well recognized as leaders in their field, but who can also give inspiring talks. And we had in mathematics education talks by also some international experts. This was one advantage of going online, because we could have actually speakers also from outside India. And that is also, the recordings are there. So you could say that this is one of our main activities, annual conferences. The other sort of thing that we are just starting, in fact, this is the first regional conference, because we feel, India is a big country. Annual conferences are difficult for people to travel and attend. It's also difficult to find a time slot where people can come. And logistics are also hard to arrange. So we thought we will do a cycle of 1 year of regional conferences and 1 year of annual conference. That's the current plan we're working on. And this, I'm very happy that this is the first regional conference, and it has turned out so well. I mean, the participation is amazing. The kind of involvement we see, it's wonderful. Of course, organization has been wonderful. I'm sure there'll be more to say later about that. So we will be holding such regional conferences also in other regions like South, East, North, and hopefully also Northeast. Roughly, these are the 5 regions that we recognize in MTA. Apart from the annual conference and the regional conferences, we also have theme-based conferences. In fact, an interesting theme-based conference is a series of conferences was held in Bangalore on undergraduate education, mathematics education. And would you like to say something about that?
Yeah, so this is something that started off as a mathematics teachers group meeting every month, college teachers meeting every month, and discussing some aspect of undergraduate mathematics. And typically the discussions center around pedagogy or assessment, typically, because, there is something that we all are bothered by. And how do you handle diversity in the classroom, different backgrounds in the classroom? So this has been the running theme of meetings, and culminating in an annual conference. And one of the things that is done there is, it started off as in Bangalore. The next time it was Bangalore and Karnataka, and this time I think there were people coming, from other states as well. One important criterion is that everybody who participates submits an abstract. So it's also important that precisely in this idea of, you get into a writing culture of writing down something that you're going to speak. So you come prepared and have some aspect of any aspect of undergraduate mathematics education. That was the idea. And this has been an interesting exercise. And I think in general, even though at school math level, there are some events at all happening in the country, at undergraduate mathematics level, discussion of pedagogy or discussion of assessment is something that we don't really see at all. So this was one of the things that was taken up by association, and it is turning out to be something interesting. Hopefully, we can have such models, such ideas elsewhere as well.
What is the theme? What is the theme then? So theme-based, when you say it, what is the theme?
Undergraduate mathematics pedagogy.
Okay, not a subject kind of. Okay, undergraduate mathematics.
But I must say that when you say undergraduate mathematics, most of the discussions revolve around calculus, linear algebra, probability, because that is the core where everybody is bothered by, and making an effective intervention. So, and one thing that again is use of technological tools. How tools can be used in the undergraduate classroom is something that people are very much interested in, and a lot of discussions around. And diversity and assessment. So these are really major challenges that keep coming up. But what is very interesting is there's a lot of ideas. Many teachers have tried out some things in their classrooms and they've got something to say. It's just that we don't have voices and platform for voices. We don't have ways of getting more people to speak up on their experiences. So that's what we need.
If any of you wants to stand up and say something in between, please feel free. Yeah? I mean, it's not, it's like I said, it's very loosely structured, it's informal. So apart from the undergraduate education workshops, we've also had workshops which are focused on, say, technology. I think Janaki has been conducting those workshops. Again, most of them have been online, I think, no? And you want to say a couple of words about it?
Yeah, we had. Am I audible?
Just hold it close to the.
Closer.
Yeah, so we had one workshop was on mathematical explorations, where technology was the primary vehicle for exploring those problems. This was online, and we've also had within the online conferences, the annual conferences, we also had workshops because we could get international resource persons also. So we had, like, for example, the developer of Mathagon himself who came and did an online session. So I think in every conference there's a lot of interest. The feedback has shown that there is a lot of interest in integration of technology, but people want, teachers have wanted specific examples of how these tools can be integrated and in which topics and so on. But yes, it has been quite an interesting part of what we have been doing at MTA.
Yeah, again, you will see these workshops and some links to some resources on the website. And like Janaki said, in our annual conferences also, we have had, pretty long workshops on use of technology like Mathagon and so on. So I'll also say something about, the MTA, what is the idea of starting of association like MTA? So this is to give a platform, on the one hand, you can have events like this where we invite some experts and then they share something. That's only one aspect. But this is really a platform for teachers, teachers like you, to make use of it in a way that enhances your work, that supports your work, etc. It's basically for building teachers as professionals. So it's a kind of platform where we come together, and the goal is that we enhance our capability as professionals, not only individually, but also in a collective sense. We learn from each other, we carry ideas, things which have been done in the past, which have been great. It also becomes a way of passing it on, renewing our knowledge of it, remembering it, etc. So this is really the idea, and we have said that it should be a platform which brings together different kinds of teachers. It's not restricted only to higher education or to school education, but it's a platform which brings together both. It's a chance for teachers at the school level to find out what are the issues, what are the important challenges at the higher education level, and vice versa. We have found that that's actually very enriching. When college teachers come to know about the problems at the school level or vice versa, it actually gives some insight into your own work, what to prioritize, how to go about things, appreciation of what's on the other side, etc. You want to say something? Yeah, I think she wants to add something. I just pause.
I'm teacher Shaila Fernandez from Perpetual Succor Convent High School, Navilim. I just would like to, I'm very grateful to MTA for having this regional conference here in Goa. I have my experience of more than 20 years of teaching, but this is the first time I'm getting this platform to interact with teachers of different levels. And it has been a very enriching experience to be here for these 2 days. I got to learn a lot from here, and I look forward to such meetings in the future. Thank you very much, MTA, for this. And I've with this conference being held, I also got a chance to know about MTA, and I've taken this opportunity and I got myself registered and I got it done.